In your word problem packet, please find the section on motion. We are going to be working with a formula. Here, D equals RT. D stands for the distance that something has traveled. R stands for the rate at which it's traveling, which usually to us, speed is what makes more sense. And T stands for the time traveled. So here we're going to talk about some car, and the speed it's traveling is 40 miles per hour. So that means in 1 hour it would travel 40 miles. So now we're going to say that that car, someone will drive for 3 hours. So if it's 40 miles per hour and you drive for 3 hours, instinctively the distance traveled would be 120 miles. So here's this basic intro problem using the formula. Rate times time equals distance. Our rate was the 40 miles per hour. Time, 3 hours, gave us 120 miles. And you will notice in here, if you actually write the labels with these values, the hours here cancels with the hours here, which is why you end up with miles left over for your label out here. Let's now take a look at the first word problem in the packet. Pause the video and take a few minutes to read the problem. You could guess and check and figure this problem out, but as I have said all semester, we will introduce a variable with a let statement and use an algebraic equation to solve and not have to guess. These motion problems we are going to set up with a chart. So here's the standard chart that we would be using. The top row, we are going to have the first column be called whatever item the two different items we're talking about, then rate, time, distance. So the two items in this problem are the two different ferries, the Big Cat and the Atlantic Cat. So they are traveling from the same place. They're leaving from Fort Myers and going to Key West. The first ferry travels at 34 miles per hour. The second ferry travels at 28 miles per hour. So the first ferry is faster. 34 miles per hour is the speed, which is the rate. So for the Big Cat rate, right here, we're going to put 34. And the Atlantic Cat is going to be a 28. Now, looking at the question, in how many hours will the two ferries be 12 miles apart? So the question is, in how many hours? So that is going to be your unknown. Let x equal number of hours. So here, let x equal number of hours. Hours is time. So in this problem, the time is unknown right here. And it's understood that both ferries are traveling the same amount of time because they want to know how long will it take for them to be 12 miles apart. So we're going to be putting x here and here. When you set up chart problems, you usually end up filling in two of the columns, in this case the rate and the time column. The third column, they didn't tell you anything about the distance specifically. You don't know the exact distance. You want to know when they'll be 12 miles apart. So the distance here comes from our formula. Rate times time equals distance. So this column here will be the 34 times x, and down here it'll be 28 times x. So again, distance we showed earlier is equal to rate times time. The time is unknown. This question is asking when they'll be 12 miles apart. Your copy may say a different number, but just cross it off if it does and put a 12 there. Now we're ready to get an equation. We need to look at the question part. In how many hours will the two ferries be 12 miles apart? These are very helpful to draw a little bit of a diagram for. So here's a basic diagram. They are both leaving Fort Myers, heading towards Key West. The Big Cat is traveling faster, so it's a little farther ahead. Atlantic Cat is slower, but they're both heading in the direction of Key West. A key part of this diagram now is they want to know when will the ferries be 12 miles apart. So the Big Cat basically is ahead of Atlantic Cat by 12 miles, so they're 12 miles apart. Translating this diagram to an equation with words, it means that the Big Cat's distance minus Atlantic Cat's distance will be equal to 12. Well, we're going to look up at our chart, and we have our distance expression for the Big Cat and the Atlantic Cat. So look in your distance column in your chart. The Big Cat distance was 34x minus Atlantic Cat 28x equals 12. And this is a simple enough equation for us to solve. So we get 6x equals 12, x equals 2. So that means after 2 hours, they will be 12 miles apart. You could come back into the expressions here to find the distances. 34 miles per hour times 2 hours will be 68 miles. 28 miles per hour times 2 hours would be 56 hours. 56 miles. Now take a look at the second problem and take a few minutes to read that. So, motion problems, set up your chart, item, rate, time, distance. The two items are the two friends, Jody and Abe. So they're horseback riding on the same trail in the same direction, so it's the same idea as number one. They're heading in the same direction. Jody's horse travels at 8 miles per hour. So 8 miles per hour is speed, again, which is rate. So Jody's rate here is going to be 8. While Abe's horse is slower. So we don't know Abe's horse's speed, which means his rate. We don't know. After 2 hours, they are 4 miles apart. Find the speed Abe's horse is traveling. So first of all, the question is our unknown. Find Abe's horse's speed, which is rate. So here, let x equal Abe's horse rate. You need to understand that speed is called rate. So in the chart under Abe rate, we're going to put X here. Now, next sentence here. After 2 hours, they are 4 miles apart. The 2 hours, they're telling you, is the amount of time they actually did ride for. So this time, the 2 hours is given, which is our time, so we're going to put 2 right in both of these spots. So the time is the same for both horses, but the speeds or rates of the horses are different. Now we can fill in our third column using our formula. So if you didn't have this written down before, rate times time equals distance. So our distance column here is these two multiplied together. So this will be 16, and this one will be 2x. So here's our fundamental diagram again. Jody is the faster horse, Abe was slower. So Jody is going to be farther ahead than Abe. And this difference here in their distance is, we're looking for it to be 4 miles apart. So I always find it helpful to write these word equations first. So Jody's distance minus Abe's distance is equal to 4. Now you just go look at your chart for what you put in the Jody's distance, which is 16, and Abe's distance is 2x. So 16 minus 2x equals 4. Easy enough equation to solve. So solving this equation, subtract 16. Negative 2x equals negative 12. Divide by negative 2. X is 6. So make sure you go back and answer the question. The question asked, how fast is Abe's horse traveling? So Abe's horse speed is 6 miles per hour, which is slower than Jody's as indicated. Here's a third motion problem where the two planes are heading towards each other instead of in the same direction. Take a minute to read the problem. So on motion problems, it is helpful to draw a diagram to indicate whether the two items are moving in the same direction, away from each other, or towards each other. In this case, the two planes are flying towards each other. So we have New York, Chicago. Southwest is leaving New York towards Chicago. JetBlue is leaving Chicago towards New York. And JetBlue is 560 miles per hour. Southwest is 580. So Southwest is a little faster. In a given amount of time, the Southwest plane will have flown farther. So I'm showing this line longer than the JetBlue line. So the next thing to our diagram that we can do is discuss the distance here. The distance from Chicago to New York is 798 miles. So this entire distance is 798 miles. So maybe the Southwest plane travels for 500 miles, while JetBlue travels for 298 miles. The question is, how long into their flights will the two lanes pass each other? So at what point do they meet up? So the question is our unknown, which is the time. So we're ready to start setting up a chart. So sketch out the chart that we've been doing with item, rate, time, distance. The two items we're working with are the two planes, Southwest and JetBlue. So we're going to write those in over here. And now we're ready to look at what givens we have here. The distance 798, we cannot put the 798 out here because they're not saying the Southwest plane actually flies 798 miles. the distance that plane goes plus the distance of JetBlue will equal the 798. We'll talk about that when we get ready for the equation. JetBlue travels 560 miles per hour, so that's its speed, which is rate. Southwest is 580. We are going to fill those in the rate column. So we have time, that is the unknown. So we're going to use X in the time column. So we have our two columns filled in. Distance, again, we're going to use our formula to get the distance column. It's rate times time. Here's our formula again, distance equals rate times time. So here the distance is the 580 times X and 560 times X here. Let's just take a minute here to discuss what this means. Let's say the planes are flying for 2 hours. Both of these numbers round up to around 600. So they would both have flown about 1,200 miles. Southwest would have gone a little bit further. So that's where the rate times the time equals your distance. So looking at our diagram, the distance that the Southwest plane flies, which again could be maybe 400 miles. JetBlue is a little slower in the same amount of time. It would have traveled the remainder of the 400 when they cross, which would have been 398. So at some point they're going to cross here. So the distance of Southwest plus the JetBlue has to equal 798. And that's our equation. We are going to take these two here and add them to equal 798. So finally we have an easy equation to solve. When we combine like terms here, we'll have 1140x. So here's 1140x equals 798. Divide by 1140, so 798 divided by 1140 is 0.7 hours. So we're going to do a check of this and see that it makes sense. We're going to put the 0.7 in here and do 580 miles per hour times 0.7. So this plane's going to travel less than 580 because they're traveling for less than an hour. They're traveling for 0.7. So here we're taking the 580 miles per hour times 0.7 hours would be 406 miles that the one plane flew. And the other plane, 560 miles per hour for 0.7 hours would be 392 miles. If we add these, we do get the 798 miles between the two cities.